Hello again. I know some of you are getting tired of the programming the Arduino stuff. Others of you like it just fine. So we need to start on the other half of this thing. That's the body. We need to build a body for the robot. So we're going to 3D print it, okay? But we need some sort of CAD software. Now there are a lot of different CAD software packages out there. Um, I know that somebody in the group said that they know SolidWorks already quite well. If you know it, you can use that. That's just wonderful. If you don't know any CAD packages and stuff like that, and you're just trying to get started with some really simple stuff, um, I really like this package called OpenSCAD. So that's what we're going to use. We've used this in the past. We've actually had a pretty good results with it. So let's start off with getting the software. So if I come in here and type OpenSCAD, this is what comes up. This is the Google page for it. Okay, here's the actual web page. Nothing too fancy. Go to downloads. I've got a Mac. Get your software. Get it installed. That should be fine. Okay, let me get that out of the way. When you bring up OpenSCAD, let's get that out of the way too. When you bring up OpenSCAD, this is what it looks like. Now, it's not outrageously exciting, and it's got three basic windows. One down here gives you just messages. If it gives you an error message, that'll tell you what's going on. Here is where we actually input the stuff to actually get our shapes and get our things. And this is actually just for looking around. This is a little different than your typical CAD package. You don't like grab a part, stretch it, move it like that. You actually type in the commands. So, I mean, just for an example, I could say, give me a cube. And I'd say make it 10 by 20 by 30. And you get used to the format pretty quick. And you can come down here and you can do the render is too slow. What you want to do is the preview button. Okay, so this is my 10 by 20 by 30. 10 by 30 by 20 by 30 what? It's in millimeters. So just keep that in mind. This is all millimeters in dimensions. Okay, so it gave me this cube. Nothing too fancy. If I want it not quite so tall, if I only want it 20 tall, it do that. Whatever height I want. I could just say one tall. It's just whatever we ask for. The F5 also does the preview. If you do render every time, the moment you get something fairly complex in there, it'll be a mess. The other option is you'll notice that the corner of the cube is right at 0, 0, 0. That's really convenient for some things. Sometimes you want to center the cube in the middle. The other thing we use is center equals true. And now the actual center of the cube is in the middle of the whole thing. Okay, nothing too fancy. That's easy enough to do. Conveniently, it looks just like your other programming language that we're just doing with the Arduino. And if I put 2 slashes in front of it and hit the F5 key to redraw, it treats it as a comment, so nothing happens. We also have a cylinder. And for the cylinder, we could specify either a radius or a diameter. I could say a diameter of D equals 10, and I want it to be H equals... the height equals 20. And then hit the F5 again to redraw it. And you can see that there's, it makes it out of flat surfaces on the sides. We can control that too, just to make it look a little bit better. $FN equals 64. Let's just take it up a little higher. And it makes it look nice and smooth. If I do both of these at the same time, let's see. We want this to be tall enough that when I do this, let me take this out of here. So now we're doing both. So now I've got the cube there with this piece on it like this. The neat thing we can do also is we've got other options. We could say rotate. Let me make the diameter a little smaller. Let me just go down a little bit. Let's go to 8. Let's see, is that enough? Let's go farther. Okay, so the diameter is now 6. It's still 20 tall, but it ends right in the middle here. I could put a rotate on the front of this. and then rotate it around X, Y, or Z. Now, you can see down here in the corner, there's this X, Y, and Z. It's really small. Sorry, I can't make that any bigger. I want to rotate it around the X axis, and I want to do 90 degrees. Okay, so rotate 90 and then 0 on the other two axes. And I don't want a semicolon there because that ends that line. So I'm rotating the cylinder. So now when I hit F5, I get that. Now if I take, I've got one more primitive I want to add to this. These are all the primitive functions here. I've got something called translate. And I could say translate. And again, it's going to have three numbers. I'm going to put it in zeros for the second here, just to get the formatting in. And this would normally all be on, one or two lines. I mean, I just have the text really big so you can see it easier. Okay, translate 0. So I hit F5, nothing changes. If I move this up, translate in the Z direction, you can see that it moves me up. Likewise, if I go -10, it moves me down. Now, I want my cylinder to be taller than that because I'm going to do something really funky with it. I'm going to say I want the height to be, let's do 50. So it's tall, okay. But, okay, so the Y direction is left and right now. So I want to slide it in the Y direction. And let's go Y direction, let's go 20, just to see where we're at. Okay, that's the way I want to go. I want it to go all the way through. Now the other thing that we can do is we got something called difference. This kind of looks like a subroutine that we did in the other programming. It's very similar. So I say difference, and I have a cube, that's my starting point, and then everything else gets subtracted. And I need another squirrely bracket at the bottom. So now it's going to take that cube and it's going to subtract off the cylinder that we just put in there. We may not want to subtract it off until we got it right where we want it, because when we say subtract it, it goes invisible. But now I've got a hole that goes all the way through. I mean, I could still change the translate. I could go this back to 0. And it puts it in the middle. And on the rotate that I rotated 90, I mean, technically I can rotate it whatever angle I feel like. If I wanted to rotate it only 80 degrees and make it kind of at a funky angle, you could see that it goes through at a funny angle now. So we've got options to do all sorts of stuff. Let me go back to 90. We can build stuff with this. We can just keep adding and subtracting. The other thing that we can do is, if I build something that's complex and I want to use it more than once, I don't want to have to type it all in every single time. So what I can do is I can make it a module. And I give it a name. It could be anything. My module. Could be anything in a squirrely bracket. And I could put all this in here. I'm just spacing it out because that's the way it's the syntax. So it's defined this module that does exactly that. Now I tell it to redraw and it's got nothing. Well, I never said to use it. So now I can just say my module. And I've got it. I could say translate. In my module. And it will give me two of them, but they're on top of each other. If I want to put them side by side, I could translate it in the, let's go for the X direction. So it'll be, right over here. And we'll just translate it. Let's start off with 10. How about 15? Oops. So I can really get some really interesting shapes out of this. Now, if I you know, if I move something in the module, it's going to affect both of them. Just like where this hole is. If I wanted to translate it back up 10, it gets both of them. Okay. I'm going to stop there, but what I suggest is download the software, get it installed, type in a few of these things, make some changes to the numbers, and see what happens. I mean, if you know, it's like anything. If you type something wrong, it's going to get upset with you, and it's going to tell you an error message. You go back, figure out what you left off or what extra thing you got in there, fix it, and go on. Okay, so we'll stop there.